Okay, hello. So I shall continue with the last part of the important reactions of lipid for the 3107. Okay, since we did not get to finish this just now. Okay, for the lipid compound in food, of course, it will involve many important reactions, but the one that is written or the one that is given in the slides are the most important ones. Okay, so you have to know what are the important reactions of lipid that lead to the degradation, because lipid has a lot of quality issues, especially because of the oxidation. Okay. Okay, number one is the oxidation. When we say shelf life of food, or when food is not stable, quality-wise, we are actually talking about two types of shelf life. One is in terms of the stability, in terms of the microbial stability when food become bad or deteriorates. Another one is because of the enzyme, okay, that leads to the deterioration of food. So when we talk about bacteria, for example, we talk about food safety or pathogenic bacteria, okay, that may cause food safety issues that make you sick. Another one, we have a spoilage bacteria. Spoilage bacteria will produce enzymes, for example, in order to that will cause food to deteriorate. For example, if you have milk, if you put it outside at room temperature for many days, it will become bad, right? Because of the growth of the bacteria, spoilage bacteria. At that particular time, it's not yet pathogenic bacteria that will make you sick, but of course, the milk will become spoil. It will be curding. It will be physical changes of the milk that you cannot drink, so you will just discard. So for the part of another stability or shelf life or spoilage of food, we are talking about especially the lipid-based food, which is oxidation. So bila oxidation, we are talking about oxidative rancidity. So fatty food, they will become rancid at at a given time. Like for example during storage, bila kita makan food like crepe, for example, kan, if the oil is being used and used for many times, and then it is being fried in the types of that type of oil, then when they pack it and then they sell it, it will take a few days or few weeks for the food to get to the customer, and then bila kita nak makan, dia dah become rancid. So that is the problem of rancidity. So when we talk about fatty food or food that is lipid based, you have to know the shelf life is not about the enzymes or the bacterial spoilage. It is about the chemical spoilage. We talk about the oxidation because of the rancidity lah. Okay, so general description is because of the oxidation, atmospheric oxidation. So when you're exposed to the oxygen from the air, atmosphere, so it will oxidize the fats and oil. So one of the main oxidation is the autocatalytic. Autocatalytic ni they happen for automatically. You don't have to induce any temperature, any time, any other parameters. Dia akan berlaku lah as you go along. Okay, so has an induction point and can be it is accelerated by the addition of metal. Metal ni salah satu, it is one of the compound that if it is exists in the particular food, they will accelerate the reaction. Okay, can also be accelerated by light. So kalau food yang banyak ni, if you can keep at a low light ataupun dark container or storage, then you can reduce the oxidative rancidity, and of course temperature. Higher temperature will induce, will accelerate the oxidation lah. And then also surface dependent and saturation dependent, and produce a variety of oxidation product. Okay, the reaction, the mechanism of lipid oxidation. So mechanism ni dia produce the free radical chain mechanism. Okay, so this is called initiation. Okay, if you have an R group ni macam fatty acid group, lepas tu ada H kan, R group. So when during the oxidation, it will become R. I don't know if you can see the small dot there. Okay, the R dot. Okay, ini kita panggil free radical lah. Free radical dia tak stable, this free radical kan. During the reaction or oxidation, dia become R dot plus H dot because of this RH punya chain tadi. Okay, removal of a H atom from the C adjacent to the double bond, meaning that if you have this C double bond ni, dia ada H, okay, so removal of the C atom from the C adjacent to the double bond. So H atom is usually from the methylene group. Methylene group ni is the yang R group, the one that SCH3, CH2, the methylene group. Okay. Alright. So this examples. So this methylene group will be tadi sekejap 1, 2, 3. Yang ni methylene group is the CH2. So dia become the RCH double bond CH, dia akan tukar kat sini lah, CH2, it will become C and H tu akan ada the free radical mechanism tu. Okay, so this is the methylene group lah. Okay, and then this is the initiation. Lepas tu the second part is the propagation. Propagate, dia propagate, maksudnya dia bertambah-tambah lah, propagation. Okay, so this alkyl radical or fatty acid free radical, they combine with oxygen, okay, oxygen from the atmosphere to first form the peroxy radical. So ROO dot. So this peroxy radical, ROO dot, this is the initial product during propagation. So this ROO dot, peroxy radical, then combines with fatty acid to perform hydroperoxide. So hydroperoxide and another alkyl radical. Hydroperoxide yang mana? It is the ROOH. The peroxide, ROH. So this is a very potent free radical lah. So we don't want this actually happening in food. Even dalam our body also, we don't want to have the free radical. That's why we have to take a lot of antioxidant. Okay, the last one is the termination. So reaction of these two free radical resulting in a non-propagating product. So this R and R will combine become RR, ROO tadi yang ni, this ROO ni peroxy radical, okay, will combine with another peroxy radical to become ROOR plus O2. So this oxidation reaction dia tak stable, that's why dia macam ada termination punya reaction. Okay, so RO plus R, it will become ROR, ROO dot plus R dot, it will become ROOR. Okay. And then if you have the RO, 2RO plus 2ROO, it will become ROOR, 2ROR plus oxygen. So you have to calculate ada berapa oxygen ada O dalam ni lah. So the one if already become ROOR or ROR, dia dah jadi termination. So the others, the extra O will become the oxygen. Okay. What is the impact? Okay, the impact is the loss of beta carotene. Beta carotene is provitamin A. Okay, you can also loss of fat soluble vitamins or ADEK vitamins, loss of essential fatty acid, possible build up polymeric material, and loss of protein quality because protein ni dia will react with the free radical tadi. Okay, so carbonyl amine reaction. So carbonyl amine reaction is the Maillard reaction. Kan kita ada two type of Brownian reaction in food. One is one is non-enzymatic, one is enzymatic. So yang non-enzymatic we have Maillard Brownian reaction. So what are the implication of deterioration reaction ni? Okay, other implication. One, we will have loss of color and flavor. That will lead to shorter shelf life. Okay, if you lost the color and flavor, it's part of the physical characteristic of the food, so you will lose the shelf life lah. Okay, another one is the warm over flavor. Warm over flavor ni in refrigerated food. Kalau food yang kita simpan dalam refrigerated, lepas tu kita warm dia kan. Kita warm dia, so rancidity will happen. after heating of food after refrigeration. Okay, this one kita call warm over flavor, WOF. Okay. And then at high heat of frying. Okay. Bila kita guna high heat for frying, sometimes high heat for frying kita tak control kan. We don't control the temperature. We just control how the intensity of the fires. We don't know actually how much of the temperature that we are giving to the food. Okay, most likely is more or equals to about 180 to 200. Sometimes kita bake. When baking, you can actually set the temperature. So we can have 120, 180. 180 is actually normal 180 degrees ni normal heating temperature that we use for baking. Okay. So results when oil is reused. So this is called lipolysis in deep fat frying kan. Selalu kalau kita masak yang deep fat frying, kita tak guna, we don't use the oil once kan, because oil is expensive, right? So we normally use multiple times. At what how many times does the oil can be used? Itu soalan dia, question mark. Okay. Kalau kita pergi McDonald's, if you go to fry fast food, okay, why don't you ask the worker how many times that they use your oil? Kan? Tengok dia jawab apa. Okay, dia ada quality indicator of the oil. After certain time of use, kita akan guna quality indicator to check what is the iodine value, peroxide value, and also the free fatty acid value. Okay, kita akan tengok dia punya point. At certain point, bila it is reach certain point, you cannot use the oil anymore because the longer usage of the oil will become food safety issues lah, because of other compound that is produced because of this oxidation. Okay, moisture from food can cause hydrolysis. So bila when you fry your food during deep frying, of course that nanti bila kita angkat kan, when you take up the food, kan it become a little bit more dry, right? Because the water, the moisture from the food will ooze out into the oil. Okay, so this is called lipolysis. Okay, so what happens? The oil will become darker, so color changes, and increase in viscosity. So viscosity will increase. Sebab tu kita tengok kalau yang use oil, it will become more thick than the new oil. Okay, and then decrease is smoke point. Okay, smoke point ni you can actually check using tools lah. Dia macam kita masukkan probe dekat dalam oil tu, and then you check the smoke point. So if you reach certain point, then you cannot use the oil anymore. So because of the formation of potentially toxic product. Okay, and then we have saponification. Saponification is the hydrolysis process with using a strong base, strong base or strong base lah. Okay, strong base. Okay, triglycerides will be split into glycerol and the salts of fatty acid. So these fatty acids, we call it soap, formation of soap. So this alkali soap, for example, sodium and also kalium. Okay, critical reaction in food oil processing to remove free fatty acid and other non-TG contaminants during refining. Dalam refining pun kita ada buat saponification. Okay, it is detrimental when occur in food, which leads to foaming, because we don't want foaming to happen in our oil product, in our lipid product. Okay, seldom it happen, but that's why they panggil soap, because it forms like a foaming like when you use the soap, right? That's why we call it soap formation. Okay, so it leads to foaming and soap formation, and it will lead to the off flavor. Okay, and then we also have lipid hydrolysis. Hydrolysis ini adalah apa? When water is hydrolyzed. So when we say lipid hydrolysis, is the lipid is being hydrolyzed. Okay, hydrolyzed by apa? By enzyme. Okay, so we know that in food we have so many different type of enzyme. Enzyme apa? What type of enzyme that react with lipid? lipase lah, lipase, because the name ni lipase, you see that lipase will react to the lipid. Okay, how? By water, heat, strong acid, strong alkali. So it will break it into glycerol and fatty acid. Remember, we have triglyceride, we have the glycerol backbone, and we also have the fatty acid yang SN1, SN2, SN3. So this will be broken down by the lipase enzyme. Okay, what happens if this occur? So you will have unpleasant odor resulted from the SCFA, resulted from the short chain fatty acid. So these are more volatile as compared to the long chain fatty acid. Okay, like for example from C4 to C10. Okay, so what do we do to combat, to tackle all these issues? Letak apa kalau oxidation? Letak antioxidant kan? Because the name is antioxidant, right? So you anti the oxidant to happen, right? Okay, so general definition, apa maksud antioxidant? It is the substance that slow or prevent the oxidative reaction. The oxidative reaction is because of the oxygen. So when you add antioxidant, you will reduce the reaction of oxidation. Okay, itu prevent oxidative reaction that will result in undesirable changes. Tadi we have looked at what are the desirable changes, which include of flavor, discoloration, loss of nutritive value because of the formation of free radical. Okay. Antioxidant can also be a synergist. Synergist ni dia macam ada 1 + 1 = 3 kan. Okay, 1 + 1 = 3. So dia ada synergistic effect. Okay, it can also be oxygen displacer. For example, we use inert gas. Inert gas ni like certain type of gas yang dia tak akan bagi any reaction to the lipid products, to the food. For example, we can use argon, we can use nitrogen. These are oxygen displacer lah. Kita displace oxygen kat dalam packaging tu kan. You push in the argon ke nitrogen ke, so you bagi remove all the oxygen, so nanti oxygen will not be in the packaging, so you can actually produce a non oxygen free packaging. Okay, or we can use protective coating. So banyak lah, nanti you will learn this about protective coating in one of your courses maybe. Mungkin Dr. Rose ke kan akan ajar all these coatings lah in your course, right, in your program. Okay, so major antioxidant use in food. Okay, this one you can actually see from the nanti bila pergi supermarket kan, when you want to buy the food product, please see the ingredient. Ni kalau budak food tech ni, kalau keluar je, I think basically consumer, an informed consumer should be able to read the ingredient and tell whether the food is good or not for us, right? Especially processed food, kan? What do we have in the processed food? We will have BHA, BHT, inilah dia. Okay, 2-treated butyl 4-hydroxyl anisole, butylated hydroxytoluene, propyl gallate. These are all antioxidant. Okay, macam mana kita nak tahu whether the product is the compound is antioxidant? Normally dia akan ada banyak ni OH group ni. Okay, OH group. Okay, so this OH group will react with the free radical. Okay, dia akan react with the free radical tadilah. Okay, okay, habis dah. Okay, I actually use Dr. Wan's slide from many years before, so I should have the summary and also the LO lah. So anyway, okay, so we have finished the lipid class for 4 hours. Okay, I'm sorry for the free Zoom version. We can only use it for 40 minutes, okay, but it doesn't matter. You can watch this video and by going through the lab manual, by going through the slide, you can actually get all this information, okay. So the summary, what is the take-home message for the lipid topic? Okay, one is we have to know the nomenclature. Okay, number 2 is you have to know what are the different type of lipid that is occur. That is, okay, that one is number 2. Number 2 is nomenclature, type of fat. Okay. And then you have to know the difference between kenapa, why some fat they exist in solid and also liquid. And then that will answer your question to the factors. Okay, one is the chain, number of chain, number of carbon. Number 2 is the unsaturation, okay, the double bond. Ada berapa double bond? Then you will answer the short chain fatty acid, medium chain fatty acid, polyunsaturated fatty acid, okay. And then that will lead to the melting point. Melting point ni, because like I said, quality issues of fat, kita nak like food manufacturer, consumer, kita nak yang wide range of temperature. You can use, it doesn't change the product kan. Oil ni dia cepat berubah. Once you take out from dia cepat melt because of the temperature, right? Especially in Malaysia where our room temperature is about berapa, 30 kan. When you take out your butter, when you take out your margarine ke, especially spread lah, spread, bila kita buat toast for example kan, kita nak dia nicely spread. If you use butter, it is not spread kan, you kena tunggu kan. This is like troublesome for consumer. So you buy this spread and then you put it like outside, you forgot to put it in the fridge, it become oily kan. So these are the, so bila kita letak dalam fridge, dia tak jadi the initial product balik kan. So that's why kita panggil warm of flavor macam tu lah. Dia akan berubah bentuk. Okay. Apa tadi nak cakap. Okay. Itu. And then you have to know the crystallization. Different type of crystallization will affect the parameters. So we have 3 types of crystallization. A very good example of crystallization to explain is the fat blooming. Itu paling contoh terbaik untuk explain. Okay. And then when you have different crystallization, when you saw the fat blooming, bila siapa yang suka makan coklat, dia tengok fat blooming, lepas tu now you know already, right? What caused fat blooming and why it happened. So I ask you to go and buy this expensive chocolate in KLCC, the Pakcik brand, and then you can compare with the normal brand and see the texture, the satiation. When you eat, it should melt in your mouth because it is 37 degrees. That one, we talk about cocoa butter substitute. Then you go to the application, kan? Okay, then we go to the reaction. Reaction of lipid. Apa reaction yang important yang lipid that will affect the quality? Number 1, of course, oxidation lah. Oxidation, why? Because dia tak stable. Because lipid dia ada double bond. Dia tend to be single bond kan. Dia tak nak double bond tu. Okay. So that's why it is not stable. So it becomes rancid. So in industry, one of the way is to add antioxidant. Okay, other than that, you also have to know what type of reaction ataupun modification is being done in food industry in terms of application. Why the industry is doing that? Through blending of oil, through interacidification, through hydrogenation. So example of hydrogenation, margarine. So these are all the important points that I tell you to take home message. When you after you learn fat, this is the take home message that you should be able to tell, to learn and to tell other people that have not learned about fats and oil. Right? If you are able to do that, that means you already cover the LO. Okay. All right, so I thank you very much. I'm sorry for the lot of hiccups during the classes today because of the free Zoom version. So hopefully you get this message. All right, and okay. So we will have one quiz for the lipid topic. I will let you know when we will do it. We will do it online in PUTRA+ only. Okay, you can just set the time and you can do it like 20 minutes or so. Okay, so I will see you next week in another class. All right, take care everyone.